Algebra Chapter 8, we want to wrap up our discussion of exponential functions by looking at the graphs of these exponential functions. And much as we did with the radical functions, we want to identify a couple of key points or key parts of the graph and then be able to use transformations to move those key points so that we can quickly sketch these graphs. So again, as we see an equation y equals a times b to the x, we want to recognize that this is the type of graph that we'll be looking at. So the picture of the graph should come to mind when we see the equation. And if b is a number larger than 1, it's going to be a growth. If b is a value between 0 and 1, we know it's going to be a decay, so it will be going down. Now, there are a couple of key points to the graph, and then again, as we talked about in those other lessons, the labeling of those is going to be what I'm going to be grading, because that's the only way I know that you know where the graph should be. The shape of the graph doesn't change, so the only way for me to tell if we kind of know what we're doing is if you label where the graph should be. So the first thing we want to look at is the fact that 0a will always be on the graph. You remember 0a is the initial population. When I plug in 0 for x, the b to the 0 power is 1. 1 times a is a. So when we substitute in 0 to the equation, a will always be the values that's produced. So 0a will always be on the graph. So you want to label that point 0a and then whatever that point is. Now, this is the parent function. The second thing that you'll want to label is the asymptote. And the asymptote is the horizontal line y equals 0, or in this case, the x-axis. The only thing that's going to move that x-axis or to move that horizontal asymptote is if we have a vertical shift up or down of the function. And you remember that will show up out here. If we have something like +3, that moves the entire graph up 3, so you would have the horizontal asymptote being moved up 3. Any other transformation of the graph, a stretch or a shrink, a vertical stretch or vertical shrink, will not affect this asymptote, so only a vertical shift will affect where the asymptote lies. Now, these are the only 2 points that you need to label on every single graph. But there is one other point that I'm going to need you to do, and that is you need to choose another point over here for x and graph it. In other words, you need to choose an x value, anything that you choose, so that you can see how quickly or how steeply this graph climbs. If the graph is a decay, you'll choose a number over here. Now, very quickly, let me explain to you why. We know that 0a is on the graph, so I know that this side of the graph, if it's a growth, will always be getting close to 0 but never actually touch it. So when I get to this point here, the question is, how quickly does it climb? Does it climb very slowly out here like this? Does it climb a little bit quicker? Or does it climb very quickly? We don't know what this side of the graph looks like. The only way to know for sure is to have another point out here graphed so that we can see how sharply this graph climbs over here on the right side. If it's a decay, we know that again this will be on the graph, and as it decays it will get closer and closer to 0 over here. The question is, how steeply did it come down? Did it come down very slowly like this? Did it come down more like this? Or was it a very sharp decline? So you would need to pick an x value over here in order to help you figure out what that side of the graph looks like. So while these are the only 2 points that I'll be looking for that help me see the label, the other side of the graph, in order for me to know how, if you determine how sharply it climbed, is for you to pick an x value. And again, that value will be up to you, so you can decide what you want. But there does need to be one other point labeled or graphed on this side. For our first example of graphing, we want to graph y equals 0.75 to the x. So we have y equals 0.75, and I'm going to change that to 3/4 because that's what 0.75 is to the x, okay? And now this is the b value, so what's the a value? There's nothing here, but remember we can always put a 1 here because 1 times this won't change it. So I have an A value of 1, and I want to know what that is because remember 0A is on the graph. So let's go ahead and graph this. So we have to label our axes. We need to put a scale on each one of these, so I'll use this scale here. Now the point 0A is on the graph, A is 1, so I have the point 0,1 is on the graph, so you'll need to label that. I also realize that the x-axis, or y equals 0, is the horizontal asymptote, so I need to label that. And again, those are the 2 points, or the 2 items of the graph that I'll be looking for when I'm grading your homework or your quizzes. Now, as I look at 3/4, the b value is between 0 and 1, so I know this is a decay, so I know it's coming down. And on this side of the graph, it's getting closer and closer to this asymptote. The question is, how steeply does this fall? How sharp should I make this turn over here? So I'll need to choose another point over here to get an idea of how quickly this climbs. Now, you don't want to pick this first one here because that's just not far enough out to give us a good picture. So you want to go 2 or 3 grid lines out when you pick your value. I'm going to just go out here to the second line, so this is -2. So I'm going to substitute -2 into my expression. So that means I'm going to have y is equal to 3/4 to the -2 power. Now that's a negative exponent, so I'll have to work with that. So that means I raise both 3 and 4 to the -2 power. So I have 3 to the -2 over 4 to the -2. Now, to make both of those positive so that I can deal with those, I'll need to switch places. So this will come up here and be 4 squared, and this will move to the denominator and be 3 squared. So that gives me 16 over 9. Now, 16 over 9 is a little bit less than 2. Alright, so I'll go over here. So when I'm here, this is a little bit less than 2. So it looks like this isn't really coming down very sharply, and it's going to look more like a smaller decay, so something that looks like this. So this would be the graph of the equation y equals 0.75 to the x. The second one I want to look at is this equation down here, y equals 3 times 2.5 to the x. So y is equal to 3 times 2.5, or 2.5 to the x. Now again, I want to know what A is because 0A is on the graph. So the A is 3, so I know that 0,3 is on the graph. So let me label these first. Here, this is 2, 4. Okay, so 0,3 is on the graph, and I know this is a growth, so it's going to be going up this way, so I'm going to put the label over here just so it's out of the way. And again, it's a growth, so I know, well, second thing I should do first is write the asymptote. The asymptote is at y equals 0, so we're going to put y equals 0 here. Now again, this number is larger than 1, so I know it's a growth, so I know that over here it's going to start close to the asymptote, and then it's going to grow. And then again, the only question is how quickly or sharply does it grow out here. Now this is 2.5 or 2.5, so it's going to grow fairly quickly, so I'm going to just use this value. I know I said only go 1 over here, or not to go 1 because it might be too close, so I was going to use 1, but I'll stick to what I said. I'm going to use 2. So we're going to have 3 times 2.5, so I'm going to change that to a fraction just because it's easier to deal with when I'm substituting in values. So that's going to be 3. I need to square the fraction first. So that's 25 over 4. And then nothing reduces, so that's 75 over 4. So if I divide that into there, that's going to be 1, and then 36, 19. Roughly something over 19, right? Let me have 4, it'd be 35, not quite 19, a little bit less than 19. So when I'm over here at 2, this number appears way up here, a little bit less than 19. So that's enough to tell me that this is growing very, very sharply, so I can go ahead and graph that. So even though I wasn't able to actually plot the second point that I used, I was able to use it to give me an idea on how steeply and how quickly this graph was climbing. So again, it's important to use that second value to help me see what this graph, or the side of the graph, looks like. So that's what you'll need to do when you're graphing these exponential functions. Again, 2 points that you'll need to label on every graph, the point 0a, and remember the asymptote, which will always be labeled as y equals 0. That's a horizontal line, which in this case happens to be the x-axis. If there's a vertical shift to this, meaning you have to move it up, let's say to 2, you would have to draw in the line and then label it y equals 2. The only reason we didn't draw it in here because if you put a dotted line on top of the solid line, you can't really see it, so there was no reason to do it. But if it moves up or down, then you will have to draw that in there so that you know the graph would get close to that line and then either grow or decay off of that. Okay, so that's how you graph these exponential growth and decay functions.